Hey, good Wednesday morning, everybody. Chief Meteorologist Brad Panovich here. Boy, what a doozy of a storm that was last night. A supercell moved across our area, causing significant damage, especially in northern Cleveland County and northwestern Gaston County. In particular, Cherville. Cherville was hit very hard by what some people think is a tornado, but honestly, we don't really know yet, and there's a lot of indications it may have been straight line winds. We'll talk more about why it matters and why it doesn't matter here in a minute, but let's recap the track. This started in McDowell County, moved across South Mountain State Park, northern Cleveland County, moved into Lincoln, Gaston County, and eventually Mecklenburg County. So you can see there's warnings up the entire time. In fact, these warnings yesterday were significant warnings. I had somebody say there was no warning at all for Cherville, but if you look, there was a 26-minute warning for the severe thunderstorm warning. If you look at the warning, it was pretty detailed about the type of damage that could be caused in this storm as it moved through. It's something we call a considerable tag, which means there were winds of up to 70 miles per hour likely within this cell. If you look at the warning itself, we'll go to the text here. I'll bring it up. Read the text here. This was issued at 6:14 p.m. for the western part of Gaston County. At 6:13, severe thunderstorm warning about 10 miles north of Shelby or near Falston, moving east at 30 miles per hour. 2-inch hail and 70 mile per hour winds. Look at the impacts. Damage to outdoors, people and animals could be injured outside. Expect hail damage to roofs, siding, windows, and vehicles. Expect considerable tree damage. Wind damage is also likely to mobile homes, roofs, and outbuildings. And look at this right here. Thunderstorm damage threat considerable. So this was a heightened severe thunderstorm warning. And probably one of the reasons you need to always take severe thunderstorm warnings seriously and why it's a big deal whether this was straight line or tornado winds is because people diminish severe thunderstorms way too much in our area. So let's go to the radar and start looking at the analysis of the radar here. I kind of briefly did this last night, but here's the storm. Let's specifically focus on Cherville. There is a distinct hook on the reflectivity. Now, the reflectivity, it's just showing you that the winds are coming out of the storm like this. So there's strong, what we call rear flank downdraft, which is the backside of the storm producing really strong winds. Now, just because there is a hook doesn't mean there's a tornado. The hook is an indication of that strong straight line wind and some inflow coming in like this. So there's certainly rotation within the parent thunderstorm. Whether or not that's down to the surface, that's the big question. If you saw my time lapse from our tower cam over here in Dallas, we could see the whole storm was rotating. But you could see that kind of hook moves across northwest Gaston County towards Dallas. Now, let's look at this a little bit differently. Let's look at the velocity data, which is showing us the winds within this cell. So I'm going to do the same thing. I got to pause this here. Right here, we'll back it up. Okay, let's go into Cherville right there. What's interesting is the greens are winds going towards the radar. The radar is over here at Mountain Island Lake. You can see it south of Huntersville, north of Charlotte. So you see the greens. The greens are really strong winds pushing this direction, okay? The reds are winds going away from the radar. They're pushing this direction. To get a tornado, we would want to see reds on this side with the rotation. That would indicate rotation within that storm. Now, look at the winds, though. I mean, they go gangbusters as this thing moves into Cherville. Look at that, especially right there. The northeast side of Cherville, right there. I mean, those winds right there where most of the damage occurred are around 70 to 80 miles per hour. But why does it look like it's not a tornado? Because all of these winds are in this direction. They're pushing in this. There's no winds coming back this way. The reds, remember, are winds going this direction. So that's a downburst. The wind hits the surface and spreads out in all directions like this. So from the radar analysis, this looks a lot like straight line winds. Now, it doesn't mean there wasn't a tornado in there. There could have been a quick spin up in there. But to me, man, I mean, look how wide the damaging winds are. That's wide. A tornado is literally about that big. So the more widespread the damage, the more likely it is straight line winds. And remember, this doesn't diminish the damage at all. Whether it's a tornado or straight line, it doesn't matter, folks. Wind is wind. If your house is burning and it's on fire, we don't sit there and go, What was the cause of it? It's on fire, okay? Wind is the same thing. It causes damage. We get caught up and we think a tornado is more severe than a straight line wind. It's not. If you went through Hugo, right? Hugo devastated the Western Carolinas. All straight line winds. Nobody's going to sit there and say Hugo wasn't a big deal, right? So don't get caught up in what the actual cause was. A tornado and straight line cause just as much damage. In fact, 90% of our wind damage in the Carolinas comes from straight line wind damage. Your insurance, the state, FEMA, they don't care what causes the wind. It's all covered the same. Now, one thing I hear often is people say, well, there was twisting of signs or of trees. Guys, twisting doesn't matter. This is what happens in the wind. This is straight line wind. You see the stop sign? It's twisting. Any vertical structure in a wind is going to twist. Trees, power poles, street signs. So the twisting thing doesn't matter. What's more important, and the Weather Service does a great job, when you get these downbursts, is you look at the direction that the trees are laying. Are they laying in all one direction or sporadically, or are they crisscrossing? I actually did a pretty lengthy blog post about these downbursts and microbursts and how dangerous they can be. This is what they look like, by the way. If you're on the edge of them, you can see these little swirls, these vortex. Sometimes people think that's a tornado. That's actually a downburst. That's the outflow coming from the downburst. But what we look for when we do storm surveys is the storm damage. You see the trees over here in this one? They're crisscrossing. They're laying in different directions, or they're all converging towards a line. Straight line wind damage, all the trees are pushed out in this direction. So you can see the difference in the damage. So the way the trees are laying is more important than whether they were twisted or not. So we will know later today. The Weather Service is going to be out there surveying the damage. I'm not going to be shocked if there's some tornado damage in there, but I'm going to tell you what, I think there's probably more downburst damage coming in here because the suddenness of this too shows those winds coming down to the surface, crashing into Cherville, and then lifting. Let's loop this a couple times, and you could see the bright green and then the blue. That's the burst of wind. Boom! Coming down to the surface and causing damage. The hook kind of fools you because you think, oh, it's got to be a tornado. But when you look at the velocity damage or the velocity data and the damage, it looks a lot like straight line winds. Another way I think it's straight line winds is I got video. Ryan, thanks for sending this in. This is from their security camera. Look at that footage. You see the rain all blowing in one direction. That is what we would classically call a wet microburst. So in many ways, the video damage I'm getting, the video of the damage and the video from security cameras and from the radar, to me indicates straight line wind damage, but I'm also not going to be shocked if there's a little bit of tornado damage because within that, there could have been a quick spin up that occurred. The thing to remember, folks, is this doesn't diminish the damage at all. Whether it's straight line or tornadoes, it's all the same. It causes damage. Downbursts can have winds up to 165 miles per hour. Trust me, that's going to cause widespread damage. So don't let it bother you that it's not a tornado versus straight line. The reason we got to study this is, one, we want to know for verification standpoints, and two, we got to get better warnings, and three, most importantly, this is a good reason if it's straight line wind damage for you to take severe thunderstorm warnings more seriously, especially when they have considerable tags or destructive tags like this storm did yesterday. Remember, the warning came out 26 minutes ahead of time. How many people took that warning seriously until after it was gone? So that's what we know right now. We'll find out more today. Of course, I'll post all the updates once we get them, especially on my Facebook, Twitter, and Instagram.